All right, in this video, we're going to work a distance mixture problem that also has that work rate concept kind of in it. So the problem says you can swim 1.25 miles downstream in the same amount of time that it takes you to swim 0.7 miles downstream. If the current is flowing at 1/2 mile per hour, how fast do you swim in still water? So this is a distance mixture problem. So we're going to work it like we do our distance mixture problems, where we define a D and an R and a T. Now, I'll just say D1, R1, T1. And I need a lot of room for this problem, so I'm going to write kind of small. And then D2, R2, and T2. We're going to assign either a variable or a number to each one of these. This is maybe upstream and this is downstream. And remember that this is all based on the equation D equals RT. Your distance equals your rate times your time. So we're just assigning variables or numbers to the elements in this equation for each situation, for each trip. Now the first sentence says that you can swim 1.25 miles downstream, 1.25, downstream, all right, well this will be downstream then. 1.25 miles downstream in the same amount of time that it takes you to swim 0.75 miles upstream. So here's downstream, here's upstream, same amount of time. That means that, and it never tells me how long that is. So I don't know the time, but it's the same amount, so I can say this is T and this is T. Now, the rate here and the rate here is going to be a combination rate. When I am swimming upstream, then I'm swimming against the current. And so I have a particular speed at which I swim in still water. But when there's a current, then if I'm going upstream, the current is pushing me back this way. So I have to subtract that rate of the current, which he tells me is 1/2. And when I'm going downstream, then I get to add that and I actually go farther. Now, in this problem, you can see that I'm calling my rate in still water R. So R is my rate in still water. It's always good to define your variables. All right, so what we're going to do then is write an equation for downstream and an equation for upstream. So I have 1.25. Now, this is going to be really better if I turn these into fractions. And 1 1/4, that's what 1.25 is really 5/4. So I'm going to say 5/4 is equal to R plus 1/2 times T. And over here, we've got 0.75, which is 3/4. So 3/4 is equal to R minus 1/2 times T. Now, there are different ways you can solve this, but an easy way to solve this would be to eliminate to solve this one for T and solve this one for T, and then put the two equations together using substitution. That's going to be the best way in this situation. So I'm going to solve this for T by dividing both sides by R plus 1/2. R plus 1/2 makes that go away there, and I get that T is equal to 5/4 over R plus 1/2. Now I'm writing it this way just briefly. We're going to clean it up. All right, now over here, when I solve this for T, same thing, R minus 1/2, R minus 1/2. All right, so when I divide over here, that goes away, and I get that T is equal to 3/4 over R minus 1/2. Since both of these equal to T, then they equal to each other. So we're going to say that 5/4, and I'm still going to leave it the way it is, over R plus 1/2 equals 3/4 over R minus 1/2. Now, this is a proportion. We solve proportions by cross multiplying. So I'm going to cross multiply to solve this proportion. So I've got 5/4 times R minus 1/2 equals 3/4 times R plus 1/2. Okay, there's my equation. Now, if I multiply both, so before I use my distributive property, if I go ahead and multiply both sides by 4, then what's going to happen is over here, the 4 is going to cancel with this 4, and this 4 is going to go away. So I'm going to have 5 times R minus 1/2. And over here, this 4 is going to go away, and I'm going to have 3 times r plus 1/2. Remember that you do not have to distribute the 4 to the fraction and what's in parentheses. If we were adding 3/4 plus r plus 1/2, if we were adding or subtracting here, it would be the distributive property. And 4 would have to be multiplied by the 3/4 and 4 would have to be multiplied by this group. But it's not the distributive property. It's just a number times a number and then times a number. And when you do that, you multiply two numbers and then you take that answer, which is this, and you multiply by the third number. So this is how we get rid of those ugly fractions. Now, I've still got some ugly fractions in here. That's okay. It's not going to be a problem. All right, so we've got 5. Now, we're going to distribute now. So I've got 5r minus, so 5r minus 5 times 1/2, which is 5/2. And then equals distributive property again, 3r plus 3 times 1/2, which is 3/2. All right, I'm just going to work with it the way it is. So I subtract 3r from both sides, and I get that I've got 2r minus 5/2 equals, and then these go away, and I just get the 3/2. So now I'm going to add 5/2 to both sides. I'm adding 5/2 to both sides, so I get 2r equals, now 5/2 and 3/2 is 8/2, which is 4. And so 2r equals 4, so r equals 2. The units here are just like the units of the 1/2, miles per hour. So my rate in still water would be 2 miles per hour.